All right. Now,
EMAG test.
Really?
what we're going to do today is on
I don't think I can test that hard.
graphs of binomial
It's
distribution.
always the same thing.
And
I don't
we
really
will
like
be
spamming
using the
tests
class
again.
pad to plot quite a few graphs, alright? So you'll be using statistics, you'll be using graph and table, and you'll be using normal graph and table as well. And I will show you things like how to generate the graph. Alright, so the first thing you need to know is we can represent a binomial distribution using a probability histogram. We can describe the shape of, you must know how to describe the shape of the probability histogram. Alright? And then you can see the difference when we start changing the number of trials in terms of the shape of the probability histogram. And you could use the probability to calculate the number of trials and so on and so forth. Right. Now, let's think about this situation. We can, for just like any other discrete random variable distributions, we can represent any binomial distribution using a probability histogram. All right?
Yeah.
Now, let's consider the experiment of tossing 3 fair coins once. Since we know that the coins are fair, the probability of getting a head is the same as probability of getting a tail. So probability of success is the same as probability of failure, which is 0.5.
Yep.
Right? It's pretty even, definitely very even, not pretty even, it's definitely even. Now, this is one condition that satisfies the binomial distribution. Then if we think about the situation as tossing a fair coin 3 times, we know that this will be a binomial distribution, all right? And we can write it as the discrete random variable x is a binomial distribution with parameters of n equals to 3 and p equals to 0.5. Probability of success, number of trial 3. All right? And you can write the probability this way. Yeah? Agree? All happy with that? Now, what I want all of you to look at is we can construct this table. And the probability histogram looks like this. How could you use your class pad? So now, on your class pad, can you go to statistics? In the menu, go to statistic mode. All right? So select calc distribution. And then in the second drop-down box, select the binomial PD and then tap next. All right? Input the number of trials and so on and so forth. I will do it with you at the same time with my class pad. So I need 0.3.
Just put x as 0.
So I need the numbers in front of me as well. So.
Pos is possibility.
Alright, with the class pad,
Probability of success.
P is probability of success. You go to statistics. I will clear everything first. I did clear everything. Alright? So if you go to calc distribution, go to, in the drop down menu, go to binomial PD. Alright? And then go to next. X. What is X?
No.
No, there's num trial.
Num trial is X, which is 3. The probability success is 0.5. Now, the thing is, it doesn't matter what X is. It has to be between 0, 1, 2, and 3. That's it. It cannot be more than 3. It cannot be less than 0.
So the start
because the trial is the start and the end of the is the start and the end of the graph, the probability. All right. So you know that it could have, if the probability of success is head, all right, you could have 1 head, no heads, 1 head, 2 head, or 3 heads. So therefore, there's only 4 possibility. Agree?
Yeah.
Agree? Yeah, agree. And so therefore, once you've done that, if you click next, it will give you, if you put 0, all right, if you put 0, next, it will give you the probability of x equals to 0. Yeah? Now, I want you to tap on this little thing here. That button there. Tap on that. I just realized that it's not here. I got to change the row.
What does x have to be 0?
So tap on that.
Because if it's outside 0.
So, if you tap on that,
3, it's not in
see,
0.
you've got what is showing you.
Because it's between 0 and 3. If it's outside, it doesn't exist.
So, it's a histogram and it's plotted
Yeah.
0, 1, 2, and 3. Now, you will see that because I haven't got that label, this should be, it will, on your class pack, it will show 1, 2, 3, and 4. What you really need to know is, in fact, the 0 should be this one. The first bar is 0, second bar is 1, third bar is x equals to 2, and the fourth bar is x equals to 3. Alright? Now, you can use your cursor. It will give you different probabilities. So here is 0.25, probability of getting x equals to 0 is 0.25. If you use your cursor, go to the next one, 0.375. So you can plot this and you can actually see the probability of x equals to something. Alright? It's useful in a way because sometimes you do need to get all the numbers. Alright? You need to have a look at the graph. Happy with that? Alright, if you're happy with that, what I'm going to do is go into the next bit. Which is alright. Now, like I say, if you look at my lesson slide, it says in there on my lesson slide, the x-axis is not quite correct. I put the word not quite correct. The first bar is when x equals to 0. Second bar is when x equals to 1. Alright, it's just that class pack can't handle that. So you must make sure that you know that that's the reason.
Yep.
So x equals to 0, 1, 2. This is the number. You can see that when you're up there, that is very clear that's 0. Alright? Now, so the focus question for you now is, why is it symmetrical? Yeah, it's uniform. So it's 50% failure and 50% success. Alright? Now, what if we toss the coin 8 times, 20 times, and 50 times? Can you go back and use your class pack to plot the graph? So, if you want to plot the graph, oops, wrong one. You go back, tap on back, go back. This time, keep your x at 0. Num trial is, let's go to 8.
That's a big
The
number.
possibility of success is still 0.5. Tap next, and then tap the drawing. You can see that it comes up with this. Alright? You've got again symmetrical. From probability of x equals to 0, x equals to 1, 2, 3, 4, 5, 6, 7, and 8. Alright? Happy with that? Yeah? Alright? 0 heads to 8 heads because that's 8 trial now. Alright, try going to 20 and 50. Go to 20. Next. And then do the drawing. What I want you to observe is a shape. It's all symmetrical, correct? Now, going to 50, you have to change the scales. So if you go to 50, and if you tap next and draw it, it looks as if it is skewed. But what happened is, it did not go all the way to 50. So you need to go to the arrow and change the X max to 52 so that you can see the whole lot. If you change the X max to 52, you can actually see that again is symmetrical. Yeah? Got it? So you need to be able to do this. Everyone got it? Got so far?
What did you do? Wait, what did you do to zoom?
Changes X max.
Yeah. Yes,
So
change
50,
that.
yeah.
That's fine.
And it's X max to 52 or whatever.
Wow.
Then you can see it is symmetrical again. Alright? Now,
Yeah,
here, this is what I've plotted. Alright? So, you can see that these are all binomial distribution, and one, I've got trials of 8 times, trial of 20 times, and trial of 50 times. Alright? Now, how would you describe histogram of this distribution?
better go.
How would you describe it? Symmetrical. So, symmetrical. The reason is because the probability of success P is equal to 1 minus P, 0.5. Alright? So it has symmetrical distribution regardless of the number of trials. So if we sum the areas of the columns of each histogram, the sum of this area equals to 1. Okay, it's equals to 1, definitely. Alright, now, let's think about another situation. If we have two biased coins, one coin D with the probability of getting ahead is 0.8, and the other one coin E, the probability of getting ahead is 0.2. Alright? Now, if we toss the biased coins 4, 20, and 50 times, what would happen to the histogram? Alright? So we know that for coin D, this is the binomial distribution, and the success is 0.8, and the success is 0.2. So n, we're going to look at 4, 20, and 50 times. Alright? Now, again, go back to your calculator. Can you plot your histogram with n equals to 4 and the success is 0.8? Alright? And then 20 and then 50. I've plotted it, but I do want you to actually do it. Play around with it and make sure that you could plot it. Again, with the 50, you need to bring this all the way up to at least 52. Alright? Now,
How did it go to 52 if it's only 52 tries there?
it's because you want the scale to be 52 so you can plot up to 50. If not, if you expand the scale to 50, it will cut it at 48. Is the way it's programmed, that's all.
Yeah.
Alright? Now, here, if you recall your statistics distribution, it looks something like this, right? They are numbers. So these are all actually skewed to the
Right.
Left.
skewed.
Oh,
Look
yeah,
at the
skewed to the
tail.
left, yeah.
Not look at, you always think about the tail. Where the tail is pointing. That's skewed to the left or negatively skewed.
Yeah.
Alright? What is telling me that the expected value, it's high because you know that 0.8, the probability of getting hit is it's high. So therefore, you can see that the mean value of 16 will have the highest probability, which is 0.2182. Yeah? You can see that. So the other thing that you should have to observe. So if the trial is small, it's very obvious. But if you look at this, just that little bit there, without ignoring those bits, it gets a little bit more symmetrical, doesn't it? At this point. All right. Although we know that it's skewed, but only looking at this bit, those bars getting symmetrical. These are actually very close to 0. They're not 0, but close to 0.
Yeah.
Yeah. this is when the success of getting ahead is 0.8. What about, let's do the reverse, the next thing, which is the success of getting 0.2. Can you at least plot a couple of them? All right?
It's going to be skewed to the
Plot
right.
a couple of them, and then observe this time what happened. Where's tail pointing?
Right to the right.
Yeah, it's skewed to the right. So if it is skewed to the right, you know that the chances of getting less head is higher, right? So therefore, in 20 trials, the mean value of 4, which is the expected value, NP, N times P, which is whatever, the mean value of 4 will have the highest probability. I'm just looking, sorry, I'm just talking about 50 at this stage. Mean height for this bit. So this one, this statement applies to that. All right? That probability doesn't apply to this. The probability, the mean value is 0.2 times 2 is 4 as well. That's 10. Sorry, this is 10. This is 4. That's 10. My fault.
He's talking about expected value.
Yeah, that's expected value, the mean value. One is 4, one is 10. So the mean value of this is, expected value of this is 4. The expected value of this is 10. 0.2 times 50 is 10. Alright? Now I'm going to put everything together.
It's just n times p.
Yep.
N times P. Alright? So the next thing, when I put everything together, you can see that to the left are the graph of binomial distribution where P equals to 0.2, 0.5, and 0.8 for the respective number of trials. 4, 20, and n equals to 50. 0.2, 0.5, and 0.8. 0.2, 0.5, and 0.8. 0.2, 0.5, and 0.8. That's probability of success. Alright? Same number of trial. Same number of trial, 20. Same number of trial, 50. So observing the graph, here, right in the middle, 0.5, it's all symmetrical. Alright? Because the probability of success is the same as probability of failure. So for probability of success, 0.5, the distributions are symmetrical in shape. Now, for probability of success and P, and probability of success of 1 minus P, which is these two, 0.2 and 0.8. If this is P, this is 1 minus P, correct? Yeah? You can see that they are mirror image. Alright? So they are mirror image of this and that. Yeah? Agree? Yeah? Now, as the value of n increases, the trial increases from 4 to 20 to 50 times, you can see that this bit of the distribution becomes a lot more symmetrical. Alright? It is perfectly symmetrical when it's 0.5. I'm just talking about that bit. Alright? You've got to think about the tail. You've got to think about the tail. Just showing that it just looks pretty different from here to here to here. Same with that. That's a little bit more symmetrical, but still remember there's a tail. This one is perfectly symmetrical. So for probability of success, which doesn't equal to 0.5, the distribution are skewed in the nature with probability of less than 0.5 skewed to the right, and probability of success greater than 0.5 skewed to the left. All right? 0.5 skewed to the left, less than 0.5 skewed to the right.
Can we say negatively skewed?
Yeah. You can say negatively skewed or positively skewed, that's fine. Now, the thing is, what you need to really think about is, in next semester, we're going to concentrate a little bit more in this bit. When you've got a probability of 0.5, we can assume that it's a normal distribution, approximate as normal distribution. Yeah? That is unit 3. We'll talk about this a bit more. So all I want today is for you to be able to plot the graph and understand and describe the skewness and whether it's symmetrical. Now, here you should be able to pick out which graph is has a success rate of 0.5, 0.1, and 0.8. All right. So graph A would have probability of success as 0.5. Oh,
1.8.
no, X is success. Oops, wrong thing. Now what about graph B? Is 0.1. And probability of success for graph C is 0.8. Alright? So you can tell because 0.8, the chances of getting successful is higher. Alright? Now, the next thing is we need to think about how to determine the number of successes. Say if we are given a parameter of n and p, n equals to 10, p equals to 0.7, how do you determine k? Can you?
Just use the graph and use trace it.
No. Let's think about two ways. We're going to use stats application, the table. The table is, you will never ever have to encounter that, I don't think. Back in the dark ages. Yes. I had to do sine, cos, and tan with all this and without calculator as well.
Wait, how do you do sine, cos, and tan without a calculator?
Table.
You have a table.
Oh.
You got a table. I'll show you the table next time. I'll bring it in. I'll show you the table next time. I've got to do that in my uni, not in my uni days, in my high school day with no calculators and all these numbers.
This is in Australia.
All right? It's really time consuming. So you got to think about what the P is. So this is binomial distribution. You can see that X is binomial distribution with parameter n and p. And you can see what P is. Probability of success 0.1, 0.2, 0.25, 0.3, so on and so forth. And then think about what n is. And yeah, it's a pain in the bum. It's really a pain in the bum. But then if you use your class map, all right? This one, you need to create a list first. Yeah? Create a list so that if you've got, in this situation, you've got n equals to 10. All right? You want to think about when you create, remember if you have a table, probability of x equals to x, and this is x, 0, 1, 2, 3, 4, 5, keep going until 10. All right? So the first thing you want to do is create a list of this first on your class pad. Makes life a little bit easier. I mean, if you don't have to, if you can read the table without that, that's fine. All right? So, but not, if not, you've got to use this action, list, create, and sequence. All right? Let me go through.
So increment of 1, is that the last one?
Yes. The last one's an increment. The first one, all right. Now, this is the expression. Could be 2x, could be 3x, could be x plus 1, x plus 2, whatever. This is just saying that the variable is x, the second one. All right? The start value, the end value, the increment is 1. And then you need to assign it to list 1.
Where do you get this one from?
All right. List 1, you've got to type it in. All right, you've got to go to main first. And edit, clear everything. Clear all and clear all variables, please.
You just chuck it in the variable.
All right. So you go to action, list, create, and sequence. So you've got x, and the variable is x, expression is x, variable is x. You start off with 0, and 10, and then the increment is 1. Now, go to your keyboard, use this. Use this to assign it to list 1. You need to type it out under ABC list 1.
Oh, why would I do that? We actually have to type it.
Yeah,
Yep,
this is a variable though, any variable you don't.
Sorry?
I think you can just use any variable you want.
you can,
Yeah.
but
Use like
I use X. Alright?
Where's sequence?
And then if you type execute, it will also come up with these numbers.
Action list.
So you can see these
Create
numbers
sequence.
will be entered into list 1 statistics mode a bit later. I will show you a little bit later. So the next one that we need to create is the probability of this, which is your binomial distribution of 10, and that is I can't remember what it was. Was it 0.3? What's the success? 0.7. All right. So you want to create this list Px equals x so that you can read. This is a way of creating the table if you need to. So you go to action, distribution, discrete, binomial PDF. Let's do the PDF first. All right. So binomial PDF.
It's good.
Now you need to put
Pretty good,
in 10 and 7. You do not need to put in any other value. By not putting in any other value in front of the 10, it's telling the class back that you want it to go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright? And then you need to assign it to, again, list 2.
What does the 7 mean, sorry?
0.7 is not 7, my fault. List 2.
Chuck that into create.
Alright? So if you tap execute, it will come up with the numbers.
Yeah.
This will be associated with 0, probability of x equals 0, probability of x equals to 1, and so on and so forth. You can scroll through that if you want to. If not, just leave it. The next one, when we talk about cumulative,
Discrete.
we need to think about probability, let's say x greater or less than equals to k, or something like this. So, what we want is a table.
How?
What we
Oh,
want is a
right.
table.
Right there.
If I've got
Yeah, you
probability
take
of
every number.
x
See
equals
more
x. Alright, this is x. This is 1. This is 0, 1,
Average
2.
animator.
There's no
So
one.
what you want is to
No
create a
way.
table of
Does
the
that
cumulative. Starting with, let's say this is
No way
A,
you
this
do
is
that.
B. This is A, this is A plus
This
B.
exam, I'll do it.
And this is C, A plus B plus
Can you give me
C.
500 bucks?
So you got a cumulative
I'm not giving you 500 for that.
probability of x equals to x, alright? You got a cumulative of that. Keep all less than or equals to x. Alright? That's a cumulative.
Second up, he's got a toilet.
So you got a cumulative. Again, you start off with the action. Let's go to action. This time go to distribution. Discrete, you do a binomial CDF. The cumulative distribution function. Again, just type in 10.7. And then this time assign it to list 3. Alright, assign it to list 3, and we can use that table now. Alright? Once you've done that, I want you to go to menu and go to statistics. Here, you can see that all the statistics, this is x equals to 0, x equals to 1, x equals to 2, 3, 4, and 5, and 6. Alright? Here is the probability of x equals to 0, x equals to 1, x equals to 2. This one is a cumulative. This plus this equals to that. This plus this equals to that, and so on and so forth. You can see that this is a sum because right at the end is 1. Alright? That is a sum. So you must know that there's a sum. From there, once you've got that, you can answer the question next. Alright? So you need to answer these questions. Probability of x equals to k equals to 0.0, 0.0368. What would you do? How do you work it out? You go to the class pad, you go to the table that's generated. So you know that this is the probability of x equals to x, right? Now, you go to list 2 and look at 0.368 and then work backwards. So that is your x. Alright? You can work from the table k equals to 4. Now, if it is less than equals to k, you know that we want it as we're going to look at the cumulative. Agree? We're going to look at the cumulative. Less than 0.1503. So keep going down until you see that. List 3, and you got 0.1503. So therefore, k equals to 5. Next bit. This time you want x greater than k equals to 0.6496. There's actually nothing here that tells you that's 0.6496, right?
Yeah.
But you know that this is a sum for anything that's less than or equals to. So you need to work backwards, which means probability of x greater than k is equals to 1 minus probability of x less than or equals to k. That's important to know. Alright? Yeah? Once you've got that, you know that this, take away that is 0.6496, which is what is required. Yeah, happy with that?
Yeah.
From there, therefore probability of x less than k is 1 take away that, which is 0.3504. Now, here, you can see that k minus 1 is 6, therefore k equals to 7. Alright?
No, isn't 6? Because greater than 6, not greater
Less.
than 6.
Less than k. So it has to be less than 7.
So
Less than or equals to 7. So that is where.
If you sub in k equals 7 into the original x.
Yeah, because this is greater.
So you only get
See?
8, 9, and 10.
Yep.
But that doesn't add to.
No, it does, because you definitely cumulative the other way. So
Yeah, that's right. You that's correct, because if 1 take away that, you got that. It's a cumulative until there. Alright? So it's k greater than k equals to 7.
9, 8, and 7. Because those values, 1, 2, 3, 4, 5, 4,
Alright? So you using the calculator is one thing, interpreting it it's the other thing. Alright, knowing how to use when x is greater than k or less than k. Alright, the next one, using class pad to determine the value of n. So given that the DRV is such that x equals to, not x equals to, DRV, the distribution is a binomial distribution with parameters n and 0.2. Determine n if x equals to 0. X equals to 0 equals to 0.0352. What you need to do is realize that you have to write it out this way. Alright? Write this out this way and expand your right hand side. So you know that that equals to 0.352. How are you going to solve this?
I'll make that 1.
Sorry? Yep, solve it on ClassPad. Use the solve function and type this in ClassPad.
Yeah.
Yeah?
14 or something. 40.99.
You got to use that. That's another way of doing it, but let's do it solving in ClassPad. Can you try solving that in ClassPad, please? Solving this in the ClassPad, you need to know how to do that. And, let me write it down, 0.2 to the power of 0, 0.8 to the power of n. Alright, now basically you know that this will be equal to 1. Alright, n select 0 is 1, 0 to the power of 0.2 to the power of 0 is 1. You can use your ClassPad. Main, I will clear everything. clear all variables. You can type the whole thing in as well. So if I do Math 3 solve, go to Advanced, NCR, X, select 0. Alright? Times 0.2 to the power of 0 times 0.8 to the power of X. What have I done? I need to equals, of course there's no answer, 0.0352. Alright? And then type execute. Oh, I don't want that, I want decimal. So it's 14.998. Since you know that it's discrete, it has to be 15. Right? No, you got to put in the equal. Just now I had no solution as well. You got to put that equals to 0.0352. Solve.
I got no.
Equals to 0.0352. If you don't put that in, you'll get no solution. If you forget that, you'll get no solution. So in this situation, if you use your class pad, n equals to 14.998, and therefore n equals to 15. Now, the other way you could do it is actually, I prefer to use solve. You can use the information, input the information into graph and table function of class pad, and read off the table. So, when you are in graph and table mode, go there, tap on there, and somewhere around here, there's somewhere for you to input. All you need to do, I'll show you. Alright, let's go to graph and tables. Go to menu, graph and table. Make sure that you clear all first. Alright, clear all. Alright, now, this little box here. When you're up here, this little box there, all right, you tap on that. Here, sorry. You got to go there and go to keyboard. Sorry, go there, go to tap on this box, not that box. Tap on this box. Go to keyboard and go to catalog. Tap on B. You can see there's a binomial PDF. You can see there's binomial PDF. So you know that you want x equals to 0. Tap on that. 0. And then you know x. It goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the probability of success is 0.2. 0.2. Click execute. Now, instead of draw graph, you want the list. Use this. The third button in, you want the list. So you can keep on going. It will give you the list. And keep going. Oh, alright. Now, you will have only 5 values. So what you want is, go back up here. In here, x and y. You want to expand the n to maybe about 50. Alright, step 1. And then your table will automatically go all the way up. Alright? So you can see that in this case, 0.0352,
No, what was the probability?
it's 15. Straight away you get that. 0.0352. Alright. Yeah. So this is probability of x equals to 0 for different n.
And then 15 would be
Yep. Alright. So the last bit. Can you use the class pad to do that? Now.
Probably not.
Yeah, of course you can. Again, use the same thing. Solve it. Solve it, and you get n equals to 17.
Yep.
Or what you could do is you could draw two lines. One is y1 equals to 0.4, y2 equals to 0.95 x. All right? So if I draw that, and I can find the line, the intersection. All right? And there's another way generating table as well. I'll do the generating table tomorrow in one of the examples. All right? So you can see that ClassPad is so powerful that you have to really know how to use it. All right? So the exercises today is mainly for you to know how to use ClassPad. All right? The few drawings is all from class. Not.
No Sadler.
What is that though?